Hello students, so today we're going to start with JEE Advanced 2024 Physics Paper 2. So firstly we discussed paper 1. The paper 1 was very easy, comparatively, like we can say it was formula based questions, or we can say from the notes only. Okay. In second paper it was also easy, but little bit of language if you are able to understand. Some questions are very lengthy. Okay. First few questions are very lengthy, we will check it out in this, and then after it was very easy. So some student may have thought like in 2024 physics paper was comparatively very easy. So as I always say, focus on all the subjects. Which one will come easy, you don't know, right? So now let's start with our first question here. See, so this question was, if I say directly, so I can say when I read the question it was very lengthy, right? So this question was to leave in the start of the paper. We can't do this question. Okay, that's a strategy you have to use, that we should not do a lengthy question in the start of the paper. Okay, easy pick up, finish it. If it is finishing before like 30 minutes, 40 minutes, then after go again and go for the hard question. That's what the strategy is, right? I hope you know. Now see, let's start this first question. What this question is saying: a region in the form of an equilateral triangle in xy plane, okay, equilateral triangle L in uniform magnetic field B, pointing in the plus z direction outwards, okay, this is outward magnetic field. A conducting loop PQR in the form of an equilateral triangle of same height L. So here this is height is given L, not the length of the triangle, okay, that you have to remember. Then he is saying is placed in xy plane. This everything is in xy plane, okay. If you are able to see, x is downward, y is this side, and z is outside, okay. In the orientation shown in the figure, at t equal to 0, the loop starts entering the region of the magnetic field with a uniform velocity v, okay. Along the plus x direction, the plane of the loop and its orientation remain unchanged throughout its motion, okay. Now see, there are two kind of questions in this chapter we can make. That is, you throw this equilateral triangle with a v speed, or you continuously keep it with a v speed, okay. So as I am entering the magnetic field, I hope you know obviously, right? If I am entering the magnetic field, these kind of questions are already done, that there is a magnetic field, and when you enter a wire, okay, then what will happen in this wire, what is the force, what is the EMF produced, that everything is solved already, right? I hope you know that thing, okay. Now what is happening here is we are keeping the velocity constant here, okay. It is just we are taking a square, okay. He is giving here triangular like this magnetic field, and you are entering with a constant velocity, okay. Here velocity is not changing as you are entering the magnetic field, because the force will produce, okay, force will come. That force is, you are applying an external force, balancing it and keeping the velocity constant. That's what he said. Now let's see what he is asking. Which of the following graph best depicts the variation of induced EMF in the loop as the function of the distance x starting from x equal to 0? So as he is going down, this triangular plate is going down. What is the induced EMF? EMF he is asking, okay, what is the graph with the x? So this is the question, okay, which one is the correct graph? That's what the question is. See, we will go very slow. If you want to see the answer, that answer is just this much only. EMF is equals to minus d phi by dt, okay. When move it here, then calculate the area of that shape, whatever it is making, and then differentiate it with respect to time with a negative sign. You will get the EMF versus x, okay. That way you can answer. But if you want to answer, that will be very lengthy. I will tell you how it will be very lengthy. Now see, what shape we have? We have here x equal to 0, okay, and then we have a triangular magnetic field like this here, like this magnetic field we have, okay. So let's draw the magnetic field here. In this shape, magnetic field is here, okay. Now this is at x equal to 0, at t equal to 0, this is like this here, exactly opposite side, right? But if we go a little bit back, like after some time, what will happen? This will come here, right? This will come here, okay. So if I find out, so this will be the only area till he is going down. Let's say I make it more down, then it will coming here. So till that area, this will be only the area it is making, right? So if I find out this area, differentiate it with respect to time, I will get the EMF, right? So let's find out this area. Now if you see here, this moved how much? From here to here, this is x, right? Okay. Now this is geometry, perfect geometry. You have to solve the geometry. That's your way, how you want to solve. I am solving in my way. That's it. This is x given to me. Okay. This small shape I'm drawing here, bigger one. Okay. If I draw a dotted line here, and this is like, if I find out this y, here this much only. Okay. So this is x by 2. By symmetry, I can say x by 2, and this is y. And this angle is how much? 30 degree, because these are equilateral triangles. So complete is 60, this is 30. So here you can write down the, what you can write down? Perpendicular upon base. So y upon x by 2. That is how much? Perpendicular upon base 10 30. Okay. So 2y, how much? 2y. Why I am writing 2y? That's just hold on. That is equals to x 10 30. That is x by root 3. Okay. This will come 2y. 2y is what? This one. This one. 2y. 2y is coming x by root 3. So you have this shape is rhombus. Okay. And area of rhombus is what? Area of rhombus. I want to get the area only, right? Area of rhombus is what? Half into multiplication of diagonals, right? So here diagonal is x, okay, and the other diagonal is 2y. The 2y value is x by root 3, right? So I can say x by root 3. So this came x square by 2 root 3. That's my area, right? So if I want to get the flux, then flux will be how much? Let's go to the next page. Flux will be how much? Flux, we have area into magnetic field, and magnetic field is given to you, right? Magnetic field, he said just B only. Okay. So flux is how much? Area is given. Area we have calculated here. X square into 2 by root 3. So B x square by 2 root 3. Okay. Now what you want to get? EMF. So EMF is what? Minus d phi by dt. Where this negative sign is just telling me the direction. That's it. Okay. Nothing else. So we don't want to go in the direction. If he is going in the direction, then we can go in the direction. Otherwise, no need to go. So if I differentiate, d is constant, x square, if I differentiate 2x dx by dt, right? So if I differentiate, what I will get? Negative is there, 2x, 2 root 3 is there, denominator, into dx by dt. Now if you understand this dx by dt is given to you, what is that? V. Okay, so I can say what is, how much value this came? Minus b vx by root 3. Okay, so I can say EMF is directly proportional to x, okay, with a negative sign. Okay, so let's see, any graph is there. So it is everywhere, it is like this only. Okay, till L it is everywhere same. Okay, so how to go there ahead? So when he will go till where he is showing, see, magnetic field is like this. Okay, so till L he goes. Till L means till here. Till here. Till here it is a rhombus shape, right? But if it goes little bit down, then it will be not rhombus, right? So how it will be? I can say this is your magnetic field. Okay, and if it go little bit down, then it will be like this. Okay, understand? It will be like this. Now you don't have to solve for that area. One method is you solve for this area, basic method. No need to find out any logic, you don't have to apply, just solve for the area and get differentiate it. Area will come in terms of x, you differentiate, you will get one more function, you draw a straight line and the answer will come. Okay, you go by that way. Or there is one more method. See, this is the second stage. I can say this is stage 2, you will follow, right? After that, what will happen? This will also come here, right? And this area will start reducing. So first what happened here, see, now I am going with the options. See, here area was 0 initially, right? So area was 0 initially. So initially EMF is also 0, obviously it is not entered, so EMF is 0. Then EMF started, okay, and then what will happen? See, area started increasing, right? Okay, with a negative sign. So area started increasing, and it will increase only. Here also it is increasing. Till here increased, still he will increase only. Okay, then after some point of time it will start reducing, right? So area is increasing and reducing. If you see by the graph, if you go by the graph, every graph have a 0 point where the EMF is getting 0. EMF is getting 0, right? EMF getting 0 means what? It differentiation, it's integration. What we said that the EMF is equals to minus d phi by dt, right? So this is getting 0 means this is hit the maxima, right? Phi got hit maxima, right? So phi is maximum. Phi is maximum when? If I find out when is the phi maximum, that is the point where the EMF is getting 0, right? Right? Because it is getting maxima and then reducing. So that maxima point is only the differentiation is getting 0, right? So I have to find out where the where the phi is getting induced, this phi is getting maximum, right? So where it will be, so where the area will be maximum, right? So I have to find out the point where x value, where EMF, where the area is getting maximum. So I have to find out that where it will be. Everything is symmetric, so I can say when it will come a star, okay, that time it will be, area will be maximum. So I have to find out the here what is the value of x at this time. This is the x equal to 0, okay, and I have to find out this x value, that how much is shifted from here to here. If I find out that x value, then I will get that where this is the point where EMF is getting 0, because here the area is hitting maximum, okay. I can say, if you don't want to go by that, just calculate this area, okay, function, and then you will get it, okay. Differentiate it, you will get it, that it will be 0 here. Now use this geometry. Either you can go by this area, okay, your wish, but I will not go with this area. See, I have to find out how much x he moved. Initially it was here like this, right? Agree? He moved here till here. So I can say that from here till here, this is L only, right? So I have to just find out this, how much this is extra, how much this is extra. Actually I draw a little bit, this is smaller. So this I have to find out, this y I have to find out. If I find out this y, L plus y is my x, directly I can say, okay. So let me draw you this correct diagram, how it will be. It will be just like this, see. It will be here only, just see here only. So it is exactly symmetric, right? So I can say this is L, right? This I know it is L already, right? So if this is L, then what is the side of the side length? Side length, let's assume that this is A. Side length is A. So what is the relation? If we don't want to go in the A, then how much is the length? You tell me the total length here. If side is given, how you say, what is the, if this is A, this will be how much? A sin 60, right? This is 60 degree, right? A sin 60. So if this is given, height is given, then how much is the side? A by sin 60. So I can say this side will be how much? L by root 3 into 2. This will be my side, okay. Now this is symmetric, this is, everything is symmetric, right? So this is also 1/3 of the side, this is also 1/3 of the side, this is also 1/3 of the side, right? So I can say this is how much? 1/3 of the side, means how much? 2L by 3 root 3. Okay, this is geometry. You have to find out this length, you have to find out this, that's it, okay. Now you can also do this, right? Don't follow my solution if I am doing like that, okay. Whatever I am able to understand, I am going with that, and I am finding out the y in terms of L, right? That's what I want to find out. Now see, here what you do is draw a dotted line. This angle is 30 again. How much? 30. This length is how much? This is 2L by 3 root 3. So this will be how much? This will be how much? If I draw it again, this is how much? The total length is 2L by 3 root 3. So this half will be how much? L by 3 root 3. Okay, and I want to find out this y. How much this will be? I can say this is 30 degree, right? So y will be how much? So I can say perpendicular upon base is equals to tan 30. So y will come from here, L by 3. Okay, y will come from here, L by 3. So I can say that x value, okay, will be L plus L by root 3, L by 3, that is how much? 4L by 3, okay. At this point of time, phi is getting maximum, okay. Why? Because area is maximum, area is maximum. If this is hitting maxima, then I can say EMF is getting 0. So this is the value where EMF is getting 0. Now you go by the option, okay. See here, he is saying EMF is getting 0 at 3L by 2, that is not, okay. Here he is saying he did at L only, okay, but that is not the true thing, right? So this option is directly rejected only, okay. This also gone. This here he said that it is at the 2L, that is also not true. So this is 3 before 3L by 2, right? Before 3L by 2 it is getting 0. So 3L by 2 is how much? 1.5L, right? 1.5L, and 4 by 3 is how much? 1.33, right? So it is before this only, so A option is the correct answer, okay. Or if you want to understand here, see, if you go by the symmetry here, see what is happening here. When both are symmetric, what is happening? That, sir, how you said it 0, that you understand. Basically what will happen, when it is moving, there will be an induced EMF, right? There will be an induced EMF. So in this length, okay, and this length to this length, it will exactly opposite EMF, okay. There will be a battery induced, right? Battery. So there will be, this battery will be opposite of this, okay, and this battery will be opposite of this battery will be opposite of this, and everything will get 0. That's why we are saying here total EMF will be 0, okay. So that's the point. So if you don't want to go, no sir, you tell me the exact solution, I want to know the equation of this line, okay. So what you do is, you find out the area, that's it. You find out the area of this function, how it is moving with the rest, with x value, okay. And as we did in this one, see, here we did, right? Here we find out the area, and then we differentiated, and then we got the function, right? That way also you can go, okay. But as we are going in the exam, so we have to be clear with the, as fast as possible we have to take the option with the correct option also, right? So if I go in the exam with the motive, right, then I will see everywhere it is same thing, okay. The difference is making in the point where it is crossing the point, okay. And these questions are already done in the notes, okay. We have in the notes, every teacher teaches these questions in the notes. But the thing is, here he changed the shape of the magnetic field through which the whatever shape you are passing, that he changed. Shape is changed. That's only the point, okay. Otherwise this question was easy, not easy I will say, because lengthy question. So in the start of the paper I will not do this, okay, for sure. I have to move forward, okay. I hope you understood. Now see the question number 2. The particle of mass m is under the influence of a gravitational field of body of mass m. Okay. You can read the question. What he is saying is, first initially only the gravitational field of capital M mass and small m mass is rotating in a circular path. And then, so initial condition is what? Let's see. Initially he is saying that a small m mass particle, okay, is rotating in a gravitational field of capital M mass in a radius of r0, okay. This is rotating, fine. Now he is saying the gravitational force will be there, right? How much is that? F is equals to G m by r0 square, okay. This force is equals to the centripetal force, so I can write down G m by r0 square is equals to what? Mr omega square. Sir, why mr omega square? Why mb square by r0? Okay, why not that one? Mb square by r. So basically what he is asking in the question, he is going in the time period, right? He is going in the time period. So I have to play with the omega only. From omega I can write down directly, omega is what? 2 pi by time period. So directly I can say. That's why I am going with the omega ratio, okay, so that I can switch it, okay. So initially this is the condition. Now he said that there is one more extra central force came, okay, related to that potential energy is given m alpha by r cube, okay, m alpha by r cube. So related to that potential energy is given. Why would I play with the potential energy when I can play with the, I want the force, I don't want to play with the potential energy. So force is equals to what? Minus du by dr, okay. So differentiate the potential energy. So if you differentiate 1 by r cube, right? So minus 3 by r to the power 4 will come, right? Minus 3 by r to the power 4. Minus minus will get cancelled out. So 3m alpha by r to the power 4. This will come. Okay. So this is the central force. So now what is the condition C? Now he is saying that this is the center. Here there was one force already, Gmm by r square, r naught square. Okay. And then one more force came. That value is how much? 3m alpha by r naught to the power 4. Okay. Now read the question. See, if the particle moves in the same circular orbit of radius r naught in the combined gravitational potential due to m and vr, okay, but in the new time period t1, okay. What you see here is basically earlier what was the force, centripetal force, Gmm by r square, right? Now centripetal force changed, right? Radius didn't change. Centripetal force is what? Mr omega square. Okay. You are saying centripetal force changed, but radius didn't change. Then who have to change? Omega have to change. Omega change means time period change. That's why he is saying the new time period is what? T1. So he's saying new time period is T1. So you compare T1 and T0, get the ratio. This ratio you have to give. Okay. Okay, fine. Let's get the ratio. So what we have to get first? Let's see this thing. We have to find out T1 square minus T0 square divided by T1 square. Okay. Separate it. 1 minus T0 upon T1 whole square, and T0, I can say time period is inversely proportional to omega. So put it here, 2 pi by omega naught and 2 pi by omega. So it will come inversely. So 1 minus omega square by omega naught square, right? So if I get omega and omega naught ratio, then I will put it here and I will get the answer. That's it. Okay. So let's get that answer. See here. Net force towards the center is equals to mr omega square, right? So write down that value. How much it will be? Gmm by r naught square, and this is outside, right? This force came when I differentiated, this came positive value, so I will put it outside. That is one mistake possible. Okay, then you will not even match the answer. Minus 3m alpha by r naught to the power 4 is equals to m r naught omega square. New omega, r naught is the same. Okay, m got cancelled out, r naught in denominator. Okay, then r naught cube. So question is this much only. See, if you got this equation number 1, this equation number 2, okay, solve this two equation, get the omega naught and omega ratio, and your answer came. Okay, now this is just a solution. Okay, so this question was just a blink. Net force towards the center is equals to mv square, mr omega square, and that answer came. Okay, so two equation, now just I will solve it. Okay, so what you do is here m got cancelled out, r naught this side, so you will have gm by r naught cube is equals to omega naught square. This is the omega naught square value. Okay, if here m got cancelled out, r naught denominator, then take it common, gm by r naught cube. Okay, and then you will get 1 minus m got cancelled out already, 3 alpha, and r naught square was there, and gm. This is equals to omega square. Fine. This is omega naught square, take it in that side. So you have 1 minus 3 alpha upon r naught square gm is equals to omega square upon omega naught square. Okay. Take this omega square, omega naught that side, and 3 alpha that side. So 1 minus omega square upon omega naught square is equals to 3 alpha upon r naught into capital G, capital F. Okay. So this only you have to calculate. See here, 1 minus omega square upon omega naught square. This value came how much? 3 alpha upon r naught square into gm. Okay, this is the answer. So A is my answer. This was very easy question, just two equation. See here, every time when you are seeing, like whenever you are practicing the question, two question always you have to answer that why I am writing that thing, whatever equation you are writing. Okay, and from where the answer is starting, not the solution. We don't have to see the what is the solution. Solution everyone can do, right? We have practiced enough questions. Solution everyone can do. Why, if you have the answer of why you are writing that value. Okay, and then after which equations you are writing. Okay, y is only the main. what I'm writing here, first equation, net force towards the center equals to mr omega square. Second equation here, this one, that's it. Then after solving, then after you can only solve. I just created here this value because I am able to create it easily. Otherwise, you solve by your way, it will get cancelled out everything and you will get your answer. Okay. So this 1-2 equation, that's it. So you have to see anywhere you are seeing after, let's say you practice, if you are analyzing how to analyze the answer. So analyzation, there you see that what is the main equation from everything is starting. Okay, like somewhere momentum conservation, angular momentum conservation, right? So from where everything is starting, that point you have to check. Understand? So there it was these two equations. That's it. Okay. Now see third question. A metal target with atomic number Z equals to 46 is bombarded with a high energy electron beam. The emission of X-ray from the target is analyzed. The ratio of R of wavelength. So R, he mentioned something, that is K alpha divided by lambda cutoff. Okay, found to be 2. The same electron beam is bombarded on another metal target with Z equals to 41, then the value of R will be. Okay. See what he is saying. He is mentioning R is something which is K alpha for 1, I am mentioning for the first case, divided by lambda cutoff. Okay. This ratio in the first case he gave 2. Okay. And he said that if I change the metal, okay, if I change the metal using the same electron beam bombarded, right? Same electron beam bombarded. So I can say that lambda cutoff will be same, right? So he's asking the new R ratio, okay, for which K alpha 2, let's name it, and lambda cutoff will be same. Why? Because same electron beam is bombarded, so this will be same, right? So now if I take the ratio, what you will got? You got the 2 by R that you have to find out, and lambda cutoff same. So what you got? K alpha 1 divided by K alpha 2. Okay, and I know that delta E is equals to HC by lambda is equals to what? Z minus 1 whole square into 1 by n1 square minus 1 by n2 square, right? So I can say lambda is inversely, n1 and n2 will be same, right? Okay, and lambda is inversely proportional to Z minus 1 ka whole square. So I will put that only. Here this is lambda only, right? Okay, so here you can see wavelength only is bombarded. The emission of X-ray of target is analyzed, the ratio of the wavelengths of the K alpha line. Okay, so these are wavelengths only. I didn't mention the lambda. That's it. Okay, so it is inversely proportional. So I can say the initial one Z1 was how much? Initial Z was 46 and final was 41. Okay, this is 46, this is 41. So it will be inversely. So here it will go 41 minus 1 ka whole square, and here it will come 46 minus 1 ka whole square, right? Basic question. R how much? 2 into 46 minus 1 ka whole square divided by 41 minus 1 ka whole square. Okay, this value you can solve and you can get your answer. Okay, whatever 46, 45 by 40 whole square is there. So I can say 2 into 46, 45 by 40. Okay, so whole square. This value you can calculate. Okay, this value will come approximately 2.53. Okay, now this is just a calculation part, so you can go for it. Okay, so these kind of questions are done. This formula, you know, lambda is inversely proportional to Z minus 1 whole square, and this also we know that lambda cutoff depends upon the beam, right? And this is not changing, so I have to find out actually the ratio of this one. Okay, so this was also a very easy question, calculation based. These kind of questions we do in the notes. Okay, now see question number 4. So this is saying a thin stiff insulated metal wire is bent into a circular loop. So you can read the question. Okay, I will explain directly. What he is saying is, so you have a circular loop. Okay, initially this is a simple rod. Okay, so just one by one understand. This is circular loop. Okay, and because of it have a mass m, so it is hanging downward. Okay, obviously. Then he said the wire loop has a mass radius r. It is a uniform vertical magnetic field B naught. So you started a vertically above B naught as shown in the figure. Initially it hangs vertically downward. Initially hanging like this. You keep my hand as a this disc. Okay, so initially it is hanging like this. Then he said initially it hangs vertically downward because of acceleration due to gravity of two conducting supports P and Q. When a current I is passed through the loop, the loop turns about the line PQ by an angle theta given by. Okay, so he's asking the angle theta. So when this is the like hanging disk, okay, and this what happened when you on the magnetic field, right? So what will come? A torque will come. What is that? M cross B, magnetic M cross B will come, and that he will turn it like this, okay, M cross B. So by that, how much it turned, how much angle it shifted, that you have to answer. Now the problem is, if the torque came, right, there was one confusion here, that if the torque came, right, so it will rotate. So when he will go up, so gravity is also giving a torque in this direction, right? If I see this way, so let me draw it for you. What I want to say is, keep it the disc like this, okay? See from this side, so you will see just a line only, right? So if you little bit draw like this, so initially it is like this, finally it will be like this, okay? Like this is the rod, okay? It is rotating, uplifting like this, okay? M is this side, okay? Magnetic moment is this side, B is this side, right? So initially it is uplifting, right? Torque. So when there is a torque, it will get a velocity, right? So it will go more up, right? But it will have the theta maximum, right? But that theta maximum, if you calculate, you will not get the answer, okay? That kind of question is done in the notes, but you will not get the answer. You will not even match one option. So this, if you get for theta maximum, you will not able to calculate. So what he is asking is, he is asking actually theta equilibrium. He is asking theta equilibrium. This was a confusion, and some students maybe have done like that, and they didn't match even one single option, right? So you have to go for theta equilibrium, and then you have to find out theta equilibrium, then your answer will match, and then you will get it, okay? That's a one, I can say, one lag that most of the, maybe some of the students have spent a time on that and they didn't got the answer, right? So what is happening here is, so you have to get the theta equilibrium. By theta equilibrium, you are getting the answer, the correct answer you are getting. See how we will get the answer. Magnetic field this side, magnetic moment this side. Okay, so let me draw it in a line only. So initially it was like this, finally it went somewhere here, this angle theta that you have to calculate, okay? This is magnetic moment direction, okay? This is magnetic field direction. If this is theta, so I can say this angle is theta, so this is 90, this is 90 minus theta, okay? 90 minus theta. So I can say then the gravity is there, right? So if I say gravity, where is the gravity? So gravity is acting this way, okay, mg. So mg, this component will come how much? If this is theta, so this will come mg sin theta. Mg sin theta, okay. So, and he gave the radius r, right? He gave the radius r, fine. So if I write down the torque is how much? M cross B, right? Torque by this magnetic moment torque, okay? M cross B, so M is how much? I into pi r square, okay? R radius, I is the current he gave, into B is B only, multiply by M cross B, so MB sin theta, sine of angle between the vectors, that is how much? 90 minus theta. This, here you have to be very careful, okay? M cross B means MB sin theta. So sin theta, sine of theta, what is the angle between them? That is 90 minus theta, okay? So this we have to be careful. So torque from here you will get I into pi r square into B into cos of theta, okay? And if we balance the torque with the mg, okay, torque of mg, equate it, torque of mg will be how much? Mg r into sin theta, mg sin theta into r, this r distance, right, is equals to this torque is how much? I into pi r square B cos theta, okay? So from here he wants what? I can get the theta only, right? Tan theta, in terms of tan theta. Like we can create cot theta also, but he is asking tan theta. So if you go for the tan theta, 1 r got cancelled out, right? And what you got here? I into pi r B divided by mg, okay? I pi r B divided by mg, okay? By rb divided by mg. So A option, okay? So my answer is A. Understood? So if you go for the theta maximum, you will not able to get any answer, okay? So no option will match, obviously. So you have to go again and go for the theta equilibrium. Then you will able to solve and then you will able to get the answer. Then you have to just balance the torque. Okay, just balancing the torque is easy. M cross B, we have studied this formula easily in the notes, so we can go by that. Here also one more thing we have to be careful, that he is asking this theta. So here angle between this magnetic moment and the magnetic field will be 90 minus theta. Okay, so this you have to be careful once. Otherwise, if you put sin theta, it will get cancelled out and you are not getting here also answer. You have to leave the question. But that is not the what happening. Here it is sin 90 minus theta, sin into angle between them. That is 90 minus theta. Okay. So one thing here careful, and if someone did for theta max, okay, then there will be a not matching the answer. So you will waste a time. So be careful with that also. Okay. Now see question number 5. So we have, so this question is in the first look it will look very big. Otherwise it is not that much big. It is an easy question only. See, not we can include this question in easy also. See how he is saying a small electric dipole P naught having a moment of inertia I about its center is kept at a distance r from the center of the spherical shell. Okay, the distance between the center and the here dipole is r, small r, and the spherical shell of radius capital R. Spherical shell is there. Okay, the surface charge density sigma is uniformly distributed on the spherical shell. The dipole is initially oriented at a small angle theta as shown in the figure. Small angle is said already. While staying at a distance r, the dipole is free to rotate about its center. Okay. Then he is talking about the small oscillation. So he is talking about the oscillation. So let's go in the oscillation only. How you will go in the oscillation? Basically, it will oscillate like this, right? So find out the torque, okay, and put it equal to I alpha. I also he gave, right? Put it equal to I alpha, and then from there alpha and theta proportionality, that will be your omega square, right? That only is asking. Okay. So now surface charge density is given, but the electric field which we write, that is not in the surface in terms of surface charge density. So we will deal with the surface charge density later on. First see here what is happening. I know that here is the dipole like this, okay, P, and electric field will be like this side, okay. This angle is given theta, okay. So I can say that torque is how much? Torque is P cross E. Okay, or directly say just P E sin theta, right? P E sin theta, okay. And this angle, the angle between them, this is given theta, right? Yes, this angle is given. Okay. So torque is equal to P E sin theta. P E, what can I write down? K Q by distance r square into sin theta. This is torque, and this torque is equal to what? I alpha. Just put it I alpha. That's it. Okay. The surface charge density is given, that we will deal later on. Just hold on. Okay. Alpha how much? Alpha came. I take that side sin theta. If theta is very small, sin theta is theta only, right? So what the proportionality came? I have K Q into P divided by R square, I R square, okay, and into theta. So this is my omega square, okay. This is my omega square. So omega is how much? Omega is under root K Q P upon I R square. Okay. This came my omega. Now I have to check the option. See, the dipole will undergo a small oscillation at any finite value of R. Okay. Now what will happen? Some students will tick that. Okay. Possible. Okay. Possible. Okay. I am telling you a thing which you have to analyze. How to analyze the options, that I am telling you. Some students may take the A option. Okay. But now read the B option. When you will read the other option, try to change your thinking about the first option what you think. Okay. The dipole will undergo small oscillation at any finite value greater than capital R. Okay. Now I click OK. When any value of R means R can be smaller than also. Okay. He is considering that case also. Means inside of the shell, there the electric field is 0. So how it will oscillate? So inside it will not oscillate. So A option is wrong. Understood? Any value of R means he is smaller than R also. There it will be not, right? So bigger than R only we have to consider, right? So it will oscillate at any finite distance value R greater than capital R, means inside the electric field it is there. So I will say this option is correct. Now he is saying the dipole will undergo a small oscillation with an angular frequency of, okay. So small r value he put 2R or 10R, okay. So solve for it. Now see, he got the value in terms of sigma, right? So let's Now put the value of, so we can say Q is equals to what? Surface charge density into area. Area is what? 4 pi r square. Small r, capital R only it will come, not the small r, right? Okay, so put that value, and K value also you put 4 pi epsilon 1 upon 4 pi epsilon naught. So I can say under root Q value is sigma into 4 pi r square P is there divided by 4 pi epsilon naught into r square. This is small r only, okay, and I is also there. Sorry, okay. So 4 pi got cancel out, and what you have? You have sigma P, and here you have 4 epsilon 4 gone. 4 is gone. Okay, epsilon naught I. You have capital R square divided by small r square. Okay, so this small r square value you can put. So if I see option, what he said, r equals to 2r, right? So 2r means how much it will come? Here it will come 4, but he said in numerator it is 2, right? So this C option is wrong. Then for D is saying r equals to 10r. Okay, so small r equals to 10r, so it will be 100. So in denominator 100 factor will come. Okay, so inside he is saying 100. Okay, fine. So I can say this is correct, right? So D option is correct for 100 by this formula. This is omega. Okay, so by this I can say D option is correct. So B and D is your answer of this question. Now see question number 6. What is saying? A table tennis ball has radius 3 by 2 into 10 to the power minus 2 meter. Okay, this is your R. Okay, this is R given. Saying mass. Okay, this I will say M. It is slowly pushed down into a swimming pool at a depth D. Okay, below the water surface and then released from rest. It emerges from the water surface at a speed V without getting wet and rises up to a height of capital H. Okay, then he is asking some values. Okay, see what he is saying is, so what you did, you had this is the level of water. Okay, I can say this is the level of water, and then you pushed it inside D, right? 0.7. Okay, fine. So you pushed it D depth. Okay, and from here you release it at V equals to 0, and he is coming up. So you pushed it, right? Means buoyancy is greater, right? So you pushed it, and then after when he came here, that time he got the velocity V. Okay, and then he raised up to a height of capital H. Means here V equals to 0. That is the thing happening. Okay, now see what he is asking. This is inside of water. Inside water. Okay, some values are also given to you. Then he's saying the work done in pushing the ball to the depth D is okay. So just to push, what is the work done here? When it was ball initially here, you pushed it till the D depth. Then what is the external force that you applied? See, I can understand that if you are pushing it, right? So how much is the net force on the ball? So means his ball is trying to come up, right? So buoyancy is greater. Buoyancy is greater than the mg, right? So I can say the F external that you will apply, it will be how much? Buoyancy minus mg only, because you want to keep it slowly, you have to bring it here. You don't have to give it any kinetic energy, right? So you have to bring it here. So you have to apply exactly equal external force and slowly bring it to here, right? So that means you have to apply this amount of force downward. Okay, and what is the buoyancy value? Everyone know density of the liquid into volume, that is 4 by 3 pi r cube. R is given to you into G, right? Let me write down density of the liquid into 4 by 3 pi r cube into G, right? This value you can put it here, F external K, right? So work done. So A part he is asking work done, right? Work done in pushing the ball to the depth D. So work done will be how much? So for the A part, I can say A part work done will be external force B minus mg into how much? This is a constant force, right? So constant force into distance how much you travel D, right? So this is your work done. Okay, this value, everything is given to you, you can calculate. Okay, easily it will come. Now come to B option. B option is saying if we neglect the viscous force in water, then the speed V will be how much? Okay, speed V. When he is coming out, that time what will be the speed? Okay, now understand what is happening here. Two methods are there. Now what is the net force? In this direction, what will be the force? The force will be how much? I can say F is equals to B minus mg will be there, upward direction, right? Now, so force is there, so you can get the acceleration. From here you can get the acceleration, right? And acceleration you got, distance you know, okay, initial velocity 0, final velocity you have to get, okay, your method, that's it. Okay, how will I apply? I know the acceleration, so I have the force, so acceleration will be how much? Upward acceleration will be how much? B minus mg divided by m. This is my acceleration, okay. So I can say for the this B option that which equation we will apply? We can say v square equals to u square plus 2as. Okay, this equation you apply, s is given as d, right? Apply this equation, u square is 0, you can go by this equation, okay. Or see here directly, b minus mg is the force, right? So there is a work done, initial velocity 0, final velocity is 0, okay. This, so apply work energy theorem, same thing. So work energy theorem if I apply, then see basically what is happening here. If you see this equation, u is 0, right? Okay, multiply by m both sides, m here. This only give me the work energy theorem also. Okay, take 2 this side. Okay, so if I take 2 this side, so this is ma and 2 this side. So this is what? Force. So this is what? Work done, change in kinetic. So you can apply the, because work done is here, I have already work done, that's why I am writing. So I can say work done is equals to change in kinetic energy. Final half mv square, initially 0. So work done is b minus mg into d is equals to half mv square. From here I will get the v. Because I have this value, that's why I am applying this. Okay. Otherwise everything is same thing only. Okay. So if your option A is matching, then directly put the value. Okay. And then you will get the v. Okay. From here I got the v. Then he is saying, so B option got. Then what he is saying? If we neglect the viscous force in water, then the height h will be how much? 1.4 he is saying. But let's see. How you will calculate? A particle thrown with velocity v. Okay, how much up it will go? That you have to calculate. How much it will go? Okay, again you can apply the work energy theorem, or you can say h is equals to v square by 2g. Okay, this way you go. Same thing, work energy theorem or this thing. Okay, so v square by 2g. Understood? So by this you will get the h. Fine. Now he's saying the ratio of magnitudes of, so this was your C part, and then he's saying D part. What? The ratio of magnitudes of net force excluding the viscous force to the maximum viscous force in the water is, okay. Ratio of magnitude of net force, okay. See, he is asking net force, that means B minus mg, excluded the viscous force, right, divided by the maximum amount of viscous force in the water. Okay, viscous force maximum when the velocity is maximum, right? So he is asking the value of 6 pi eta r v, which is after finally it is going outside. Okay, that velocity is maximum velocity because initially it is 0, slowly it is increasing. So this is v only, this magnitude is asking. Okay, so this is the final answer. Okay, and this comes 500 by 9, I think. Okay, I think it matches the answer. Okay, 500 by 9 only it will come. So I told you how to calculate. Just look at once. First we will go work done. What is that? Net force, the force, external force into d distance, right? Then B option he asked the what is the velocity is going out. So work done is equals to change in kinetic energy. By this you calculate, because work done we have calculated here. Okay. C option also you can go with the work done also. So work done, how you will go? Directly apply from the downside to upside. Okay. What is work done? When he is going up, work done is how much? B minus mg into d plus, then after downward is a force, right? So then minus mg into h. This is getting change in kinetic energy 0. From here also you will get the same h. Okay. So that's what, because this you know, so that directly you can get the answer. Okay. That's one way. And D option he is saying b minus mg upon 6 pi eta rv, you have to get the ratio. Okay. So these are the 4 answers. So some people solve with this also, okay. Solve with this also, okay. Okay. I hope you understood. This is very easy question. Values you can put. Okay, I am not here to teach you the calculations, right? Obviously you have till 10th class you learn these calculations only, right? So this way you have to solve. Okay. Now see, next question. He is saying, this question is like, this kind of questions we have already done, okay. Little bit he is increasing the language, that's it, okay. Here x, x0, x1, these are increased, otherwise this kind of questions are done, okay. Notes. Not that much hard, little bit looking lengthy, but it is not. Diagram he gave like that, just in JEE Advanced understand, sometime they just want to make you should have a fear, okay. That kind of feeling they give, otherwise if you read the question, it is very easy, okay. See. A positive singly ionized atom of mass m. So singly ionized atom. Here you have to pick the information in the question only. Okay. Is accelerated from rest by a voltage 192. Thereafter it enters a rectangular region of width w with magnetic field B naught. Okay. 1.5. So outward. Okay. As shown in the figure, the ion finally hits a detector at a distance x below its starting trajectory. Okay. So below its starting trajectory, it hits here. How it hits, that we will see. Now see what is happening. Initially charge Q, okay, he is going this way by a voltage of 192, it got accelerated, and then he enters a magnetic field, okay, outward. So he will rotate. This kind of rotation, this how it will follow a circular path, that question is aren't done in the notes only, okay. So he will rotate in a circular path, okay, of radius r, okay, and then he said that there you put a detector and he hit the detector here, okay. So he will exit at 90 degree also, right. It will hit the detector here. So this distance he is saying as x, that's it. So I can say x is equals to what, 2r, x is my 2r, right. And what is, so first of all, half mv square, change in kinetic energy when you accelerate it, is equals to q into voltage, that is 192, okay. Here x is equals to 2r, and what is the value of r? What is the value of r? R we can say mv upon qb. mv upon qb, right? So this value came, you can put it here, the x came. Okay, that's it. Answer came. See how x is equals to 2m upon qb under root of, here v value you put, what is that? 2q into 192 divided by m. Okay. Now put it this inside. What you will get? You will get the here 4 to 8 into 192. Okay, I will not simplify. Okay, q square will go, so q will come in denominator. Okay, and m square will go, so m will come in numerator. Okay, and then b inside it will go, it will become b square, right? So b square value is given to you, right? That is how much? 0.1. 0.1 square. Fine. Okay, I think 0.1 only given. Yeah, 0.1 only. Okay, so 0.1 square. So q and m is changing depending upon the option. That's why I put it here like this. Okay, so this is the value of x you are getting. Okay, so now go with the option. The value of x for H plus ion is 4 centimeter. Okay, so you put the value for H plus ion, okay, and you will get the answer. Then the value of x for an ion, atomic mass is given, okay, 144, mass number is given, 144 is 48 centimeter. So you get the answer. In the answer you will get here, I will tell you here only, answer you will get from here in meter. Everything is an SI unit. You will get the answer in meter, convert it into centimeter. Okay. Next thing, for detecting ions with 1 atomic mass and 196 to 1, the minimum height that is required, x1 minus x0 from initial point to final point, that will be how much? 55 centimeter. Okay. Now see here, he is asking, see, x is directly proportional to m, right? Where he will hit, that is directly proportional to mass, right? So he is changing that mass number only, right? He is changing the mass number, right? So I can say when the mass will be low, then x will be low, right? X will be low, and when mass will be high, then x will be high, right? So that only range he is asking for minimum and maximum. So what you do is you get the x for the value 1, okay, and subtract. So you get the x for how much? This is 196, right? Get the x for 196 minus get the x of 1. This value you have to get in the C option. Okay, that only is asking. This x 196. If the 196 particle with the atomic mass number 196 if it also hit on the this, you will follow a bigger circular path, right? Okay, it also hit, and the smallest also hit. That only should be the minimum width, okay, of this. So that only you have to tell here, this value. Understood? So you can put in this one formula only and you will get the answer. Okay. Now next thing what he is saying, the minimum width of W of the region of magnetic field for detecting ions with atomic mass number 196 is 56 centimeter. Now see here, he is not asking this he is asking width, with this width. Now go to our notes. Okay. In notes we have done questions where sometimes this width was very less. So what have happened in that questions is, you have exited the magnetic field. You came here, this was magnetic field, and you wanted to travel the circular path, but you didn't able to complete and you exited, right? So he want to make sure that it should complete the circular path, right? So how much width he should keep? Okay. So how much he should keep when he is entering here? Okay. It should complete the circular path, means this should be, radius should be greater, right? Radius should be less than the width. Width should be bigger, right? So minimum case I can say width is equals to r and x by 2. R is what? X by 2. So you find out the value of x by 2 for 196. That's your answer, right? So I think somewhere here also you calculated those things. So you can get for 196 also, okay? So W you have to calculate. W is what? Nothing but just for R you have to calculate, that is x by 2, x formula is given to you. Okay, this value you calculate for mass number 196. Okay, then you will get the answer. Okay, calculation part you can handle. Okay, so this, what was the main thing here? Actually this kind of questions we have done in the notes. Charge accelerated, so this formula is done. Then this thing mv upon qb, this is very much used formula in the notes, right? So this you have to remember, okay? And then we solved it and we got the answer. Now with this formula only, all the options will get. Now by look, this question is looking very big. Okay, diagram is looking very horrible, but it's not, right? Because we have studied, just report a detector and drawn some dotted lines and like this. That doesn't mean you will get confused, okay? Read once, you will get the answer. But initially if it is by the look, it is looking big, I will go for a smaller one, okay? It's okay, okay? But when second time I will read it, I should get that, okay, this is only happening, this we have studied it, okay? Generally, what we study in the notes is, we generally, teacher give the values or something like that by spoken only. So when we are writing the notes, the question doesn't look that much big, okay? But here he explains everything, he gives all the values, okay? So that then it will, sometime it looks big, okay? So you have to be careful with that. And this is also doable question. Scoring. Okay. Next, question number 8 is saying the dimensions of a cone are measured using a scale with least count. Okay. This is basic question given from the, like, very basic question. Okay. See what he is saying. Even I don't use this board, you can go with this. Okay. See what he is saying is percentage error we have to find out in the volume. Okay. So volume, we know volume is what? 1 by 3 pi r square h, right? Okay, this is the volume of the cone. Okay, so delta V, differentiate, take ln and differentiate from notes formula, 2 times of delta r by r. Okay, or he is given the terms of diameter, so you write down in that value. Yeah, diameter. So r is d by 2, so 1 by 3 pi d by 2 ka whole square into h. So that is some constant which is pi upon 4 3 is 12 into d square h. Okay, I have to take that only. So I can say delta V by V is equals to 2 times of delta D by D plus delta H by H. Okay, so let's write down this value. So 2 into delta D by D. So least count is given 2 mm. So I can say 2 into 10 to the power minus 3. I'm writing in the SI unit only so that I don't interchange. Otherwise I can put everything in centimeter, I will get the answer. This is 20 into 10 to the power minus 2. Okay. And plus delta H, that also same least count. So I can say 2 into 10 to the power minus 3 divided by 20 into 10 to the power minus 2. Okay. And this value multiplied by 100 will come in the percentage. This came your percentage. I think this value will come 2 minus 3. So it will come This comes 3%. Okay, so that's your answer. It's it. Okay, simple. Okay, nothing you have to do, just formula based direct answer. Okay, next question. A ball is thrown from a location x0 y0, that is 0, 0, and initial velocity v0 at angle theta naught from positive x direction. The ball is to hit by a stone which is thrown at the same time from the location x1 y1, that is L, 0. Okay, this is given to you. Fine. The stone is thrown at an angle of 180 minus theta 1 from the positive x direction, means from theta 1 from the negative x direction, with a suitable initial speed. Let's consider this as v. Okay, this is v0, this is v. For a fixed v0, where first initial condition is theta 0 and theta 1 is 45, 45, there the time taken is t1 to hit. And second condition is theta 0 and theta 1 is 60, 30, it hits the ball after time t2. In such case, what is the ratio of square of ratio? Okay, fine. Let's go. So here we are seeing that initially condition that thrown with v0, okay, and here thrown with, let's say, v. Suitable velocity. What is suitable velocity? I will tell you. 45 degree, case 1 I am taking. Okay. Okay, and distance is L, because this is 0, 0, this is L, 0, right? So distance is L, right? Then he said, let's say this is also 45, he said. Okay. So he said suitable velocity that it can hit. Now, if you go by the relative velocity concept, their vertical component should be equal to hit, because they are projected at the same time, right? So their vertical component should be equal. So vertical component equal means what? V0 cos sine 45, cos 45, write down sine 45, same thing. V0 sine 45 is equals to V sine 45 in vertical direction, always, right? In relative velocity, G will not come, right? So V0, so V came V0 only in the case 1, right? So here I can say V is V0. Now, after how much time they will hit? So time will be decided here in the horizontal direction, right? Vertical will be vertical only. Horizontal, it will be decided how they are coming close, right? So if I go with the relative velocity concept, I can say distance travel is L, okay, and relative velocity is how much? The velocity will get added. Take this side component, this will be how much? V0 cos 45, and this will be how much? V cos 45, okay. This will get added in relative velocity. So I can say velocity with which they are traveling is V0 cos 45 plus V cos 45, okay, and this is equal to distance L and time taken T1. That's it. V is equal to V0 you put here. So how much T1 you got? T1 is how much? I can say V0 V equal cos 45 1 by root 2. 1 by root 2, this will come root 2 V0. So this will come this side. So L upon root 2 V0. Okay. Now second answer also I have to get in terms of V0 only, right? This ratio only. So let's get it. What he is saying that 60 and 30. Okay. So he said projected with V0 at an angle of 60 degree and the other particle with velocity V, let's say at an angle of 30 degree. Okay. This is what. So again they are hitting suitable velocity. So I can say V0 sine 60 vertical direction is equals to V sine 30, right? Okay. So V0 sine 60 what? Root 3 by 2. This is 1 by 2. So I can say V is what? Root 3 V0. This came. Horizontal direction again same relative velocity how much? V0 cos 60 plus V cos 30. This is the velocity of approach. Velocity is equal to distance same L divided by time taken, this time T2. Okay. Put the value of V. V0 cos 60 sin 31 by 2 plus V value root 3 V0 into cos 30 sin 60 root 3 by 2, right? This is 3 by 2, this is 1 by 2, 2 V0, right? So put that side, you will get T2 is equals to L upon 2 V0, right? So T1 by T2 if you want to get, or T2 by T1, T1 by T2 ka whole square. Okay. T1 by T2 if I want to find out, T1 upon T2. So 2 root 2, right? T1 root 2. So this will come 2 upon root 2, that is root 2. So square if you want to find out T1 by T2 ka whole square, that will come 2. So 2 is your answer. This is basic projectile question of relative motion. Okay, so if you are going for relative motion, I can say vertical components are equal, right? So because they want to hit each other, right? So obviously in the vertical direction they should be always like going up and coming down. They should be always horizontal in vertical direction, every same height. Then only they will hit, right? So that's what happening. And horizontal direction, with the horizontal component, they are moving continuously close to each other, right? And they will hit. Understood? So in the horizontal direction there is no acceleration. In vertical direction there is acceleration, but they are, if projected with the same velocity at same time, then they will be at the same height, right? At the same time. That's what condition is, and this is already taught to you. Okay, basic thing. Just the thing is, like, question is looking like x0, y0, 0, 0, 180 minus theta 1. If you are able to understand and draw a diagram, simple. Okay, by the given information, draw a diagram, simple diagram. Then you will able to understand what the question is. If you understand the question, then this is basic, right? Okay, I hope you understood. Now see question number 10. He is saying a charge is kept at a central point P of a cylindrical region. The two edges subtended a half angle theta at P. Okay, half angle is given at P as shown in the figure. When theta is 30 degree, then the electric flux through the curved surface is phi. Okay. If theta is 60, then the electric flux will be through the curved surface. Okay. So here we will use the concept of solid angle. Okay. So understand one thing I want to tell. If anyone doesn't know what is solid angle, just understand, if here given to me this is charge q. Okay. Then through this disk, through this particular area, how much electric flux will be there? Okay. That if I want to calculate. Okay. So if this angle is given to, half angle is given to me theta, then the electric flux comes is q upon 2 epsilon naught into 1 minus cos theta. Okay, this is the formula. Okay, understood? So this is the formula we are going to use. This formula comes from solid angle. Okay, this formula we are going to use. Okay, now see how. So he is saying that through this cylindrical surface, right? So understand now how. Basically, if I total flux will be how much? Q by epsilon naught, right? Okay. If I subtract minus 2 times of disk, how much flux is going out of this disk and out of this disk? If I subtract from total flux, right, then I will get my flux, right, which I need from the curved surface, right? So the flux that I need is how much? Q by epsilon naught minus Q by 2 epsilon naught into 1 minus cos theta, right? Multiply by 2. Okay, there is this above and this below also, right? So 2 times. So this will come, phi is equals to, this got 2 got cancel out. So Q by epsilon naught common, 1 minus plus. So Q by epsilon naught cos theta, right? Minus 1 plus 1 minus 1 plus cos theta. Q by epsilon naught cos theta, right? So first one 30 degree. So 1 is how much? Cos 30, and phi 2 is how much? Q by, so this is, he mentioned phi only. So this is phi 2, Q by epsilon naught is cos 60. So how much is that? So I can say phi 2 is equals to cos 30 sin 60 root 3 by 2 divided by cos 61 by 2. So this will come, flux 2 is what? Flux upon root 3. Okay, so root 3. So he is asking, I think, this only, right? So answer will be 3. N will be how much? 3. That's it. So you used a concept of solid angle, this only. That's it. Okay. This also we have question of solid angle in the notes of how to use the solid angle. Okay. Derivation is not in our syllabus, but this we used. Okay. Solid angle concept, that if the charge q is there, it is flux is every side, right? So from this disk, which is at subtending at angle theta, then how much will be the flux passing through this particular area that we mentioned here. Okay. See next 11th question. Two equilateral triangle prisms P1 and P2 are kept with their sides parallel to each other in vacuum as shown in the figure. Okay. A light ray enters P1 at angle theta of incidence theta. Okay. Such that the outgoing ray undergoes a minimum deviation in prism P2. So minimum deviation is in the P2. Okay. If the respective refractive index of P1 and P2 are given, then theta value will be how much? Okay, see what is happening here. So you have two prisms, one is this way, very easy question, okay, don't worry, and other is this way. Both are equilateral. Then he is saying that you incidence a ray. So you incidence a ray at angle theta, like this angle theta. Okay, let's say that it got this side and this is, let's say, R1, okay, and then it went outside, okay, it went out with, this is R2, this is R2 angle, okay. So R1 plus R2 is this 60 degree, right? We know already, right? And from here it went out R2, and let's mention this as alpha, okay. So this will go inside this, and this is exactly same shape, right? So I can say this one is alpha, inside this angle is alpha here, okay, because these lines are same lines only, right? So this angle will be same, right? Okay. So now we can say this is not looking symmetric, so let me draw it perpendicular exactly like this, okay, it will be, so this will be alpha. Then he went here, so least deviation, right? So I can say if this is 60, okay, and I know if it is minimum deviation means this angle will be 30 degree, right? Okay, this angle will be 30 degree. Minimum deviation he said, right? Minimum deviation in P2. So the angle will be 30 degree, right? Now just apply reversely, okay? He gave the refractive index P1, P2 under root of 3 by 2 and root 3, okay. This one is under root of 3 by 2 and this is root 3, right? Yeah, okay. So these are values given, so apply here. So what we can say, 1 outside 1 sin alpha is equals to root 3 sin 30, okay. So I can say how much it will come, sin 31 by 2, alpha will come 60, alpha 60, right? So now get the R2, okay. If I get the R2, so I can say R2, so sorry, I can say under root 3 by 2 sine of R2 is equals to 1 into sine alpha, sine 60, right? That is alpha is 60, right? Sine 60 root 3 by 2, root 3 by 2, so R2 will come how much? Root 3 by 2 to root 2, so this will come 45 degree, okay. If R2 is 45, then R1 is, I can say R1 plus R2 is 60, right? R1 plus R2 is what? 60. This we know already, right? Okay. So I can say this is 45. So R1 will be how much? R1 will be 15 degree, right? Okay. So from here I can say, if I apply here, then I can say 1 sin theta is equals to under root 3 by 2 into sine of 15 degree. 15 degree. Okay. And he asked, see here, he asked this only. So sine inverse you take this side. If you take sine this side, okay, so sine inverse under root 3 by 2 matching sine. So he wrote in the terms of pi, okay. So if you write down the 15 degree in terms of pi, if you write down 15 degree in terms of pi, then what it will come? You write down 15 degree in terms of pi, pi up by 12, okay. So your beta is 12. That's it. Okay. From here, just apply multiple times. That's it. Answer. Okay. These kind of questions, the least deviation condition, you know, R1 and R2 are equal here. Okay. And here R1 plus R2 is 60 degrees. So I will come reverse from here for the theta. Okay. And it satisfied the condition. That's I got the answer. Okay. I hope simple question. Okay. One of the scoring question in this is okay. Now see next question, which is also easy only we can consider. Okay. In the notes we do separately for infinite wire and the what is a spherical shell, right? Spherical shell. Okay, we do separately, he write together. Okay. So he is saying a uniform charge density of per unit length is given here. So lambda is given here. Okay, is passing through a spherical shell of radius 1 meter. So this is capital R is given to you. Okay. As shown in the figure, at 10 nanocoulomb charge is distributed in uniformly. So this is Q is given of the spherical shell.
Okay, if the configuration of the charges remains static, the magnitude of the potential difference between the point P and R. Okay, so P is inside, okay, spherical shell, and R is outside. Okay, in voltage, in volt is how much? Okay, so he's asking Vp minus VR. VR. Okay, so for the infinite wire, how much is the answer? Okay, we can say, we know already, this is solved. Okay, 2k lambda, okay, ln R2 by R1, right? So R2 is how much? 2 meter, and R1 is how much? 0.5. Okay, let me write on that board. Okay, in the board, if I write down, okay. Vp minus VR, I can say 2k lambda ln 2 meter outside, and inner one, the smaller one, is how much? 0.5, right? Okay, right, and then plus the potential difference for the spherical shell. Okay, so that will be how much? Kq by capital R. The inner point you have to consider capital R only, right? So that is 1 meter minus Kq for the outside one, it will be the distance. Okay, so that is how much from the center? 2 meter, right? So this will be the answer. That's it. Now put the value. Okay, see here, 2 k value is given. K value is given or not? 1 by 4 pi epsilon naught k only. Okay, so now just put the values. So this is given 9 into 10 to the power 9. Okay, lambda is given to you how much? Lambda is given 5 nanocoulomb. Okay, nano means how much? 10 to the power minus 9, right? So 9 into 10 to the power 5 into 10 to the power 9. Okay, so this is 5 into 10 to the power minus 9. Okay, and then after how much? K q lambda ln R2, this is 4, right? Plus here this is kq by 2 only, right? 1 minus half, so 2 by 2. So 1 by 2 into k is 9 into 10 to the power 9 into q. Charge is given how much? Charge is given to you 10 nanocoulomb, right? 10 nanocoulomb means how much? 10 into 10 to the power minus 9. Okay, this is given to you, right? So I hope you understood this thing. Okay, this value if you calculate, you will get the answer. Okay, I think 171. Okay, 171, you will get the answer. So ln2 you can write down 2 ln2, 2 square, then 2 will come outside, so 2 ln2. So 2 into ln2 value is given 0.7 to you, right? That way you can put the value and you can get the answer. Okay, next question number 13. He's saying spherical soap bubble inside an air chamber at pressure P0. Okay, certain radius, so that the excess pressure inside the bubble is delta P is given 144 Pascal. Okay, now the chamber pressure is reduced to 8 P0 by 27, so that the bubble radius and its excess pressure changes. Okay, radius is also changing, excess pressure is also changing. Okay, in this process all the temperature remain constant. Okay, so temperature is remain constant. Okay, so inside the bubble, number of mole constant, temperature constant, so I can say pressure into volume is constant by PV equals to nRT, right? Assume air to be an ideal gas and the excess pressure delta P is both cases to be much smaller than the chamber pressure. The new excess pressure delta P in Pascal is, okay, see here. So there was a chamber initially, let's say radius I will go later on. Here inside pressure is how much? P0 plus delta P, okay, which is given to you, and outside pressure P0, right? And volume is how much? 4 by 3 pi r cube volume. And then later on what happened? This is given to you. What is the value of this? This is, I think, P0 plus 144 given, right? Okay, so this is delta P. Finally, what is happening? So you have changed the radius, is changed, outside pressure 8 P0 by 27, keeping the temperature constant. Inside pressure 8 P0 by 27 plus delta P. This delta P you have to calculate. Okay, that's what he is saying. So consider this radius as R1 and this radius as R2. Okay, see now what is happening. Pressure into volume constant. Okay, because number of mole constant and temperature is constant. So here pressure into inside, we have to say pressure is how much? P0 plus 144 into volume is how much? 4 by 3 pi R1 cube is equals to final, what is the value? 8 P0 by 27 plus delta P into volume 4 by 3 pi R2 cube. Okay. Now see, calculation is looking very difficult, but one thing, okay, that compared to P naught 144 is negligible and 8 P naught by 27 delta P is negligible. Okay. So I will neglect here this thing. Okay. And then I will solve. So then I can say 4 by 3 pi cancel out. Okay. And P naught got cancel out, 8 by 27. So if I take power 1 by 3, so I will get R1 is equals to 2 by 3 R2. Okay. This is the relation between R1 and R2. So I have to get the relation between pressure. Okay. So I can say X is pressure, always delta P is how much? In the case of bubble, I can say 4T by R. 4T by R. So I can say radius is 4T by delta P. Okay. So in case of R1, what can I put value? 4T by delta P, which is given to you. How much is that? 144 is equals to 2 by 3 into 4T by R2, which is you have to calculate. So delta P. Okay. So from here, if you get the delta P is how much? Cross multiply, you will get 2 by 3 into 144. Okay. So this got cancelled out and you will get the answer. Okay. Now see, interesting question. Okay, paragraph. These are two questions in one paragraph only. Okay, in a Young's double slit experiment, which is very much in depth studied in the notes, each of the two slides A and B shown in the figure as oscillates about their fixed center and with a mean separation of 0.8 mm. Okay, the distance between the slits T, as so small d is given. Small d, this distance is oscillating. Okay, fine. Omega is given to you. Omega value here that you have to put. The distance of the screen from the slits is 1 meter. Okay. Capital D. Wavelength is given to you. The interface pattern on the screen changes with the time while the central bright fringe, zeroth fringe remains fixed at the point O. Fine. He is asking the 8th bright fringe above the point O oscillates. See what will happen is, this is oscillating, right? So what he is asking, 8th bright fringe oscillates with time to extreme positions. Separation between these two extreme positions in micrometer is, okay. See, this D is oscillating, right? Okay. So here the 8th bright fringe will come, right? That will also oscillate. As the D is changing, it will also change, right? It will also change. So there will be a minimum point and there will be a maximum point. Okay. So that you have to find out the separation. Okay. I think separation only is asking. Yeah. Oscillate separation between the two extreme positions. Okay. Now see, what is 8th bright fringe for? What is the formula? I can say 8 lambda d by d, right? This is only the thing. Okay. So 8 lambda is given to you, capital D is given, small d formula is given to you. Small d is saying 0.8 plus 0.04 sin omega t. Okay. 0.8 plus 0.04 into sin omega t. Fine. Omega is also given to you, right? Now he is saying P8 maximum minus B8 minimum. This value you tell me. Okay. So when it will be maximum? Okay. Here this sine function is only changing, right? With respect to time, this sine function is only changing, right? So when it will be maximum, when the denominator will be minimum. So when it will be minimum, then this value will be minimum, right? So minimum it can be how much? -1, right? So I can say it will come 8 lambda d by 0.8 minus 0.04. This is the maximum value of this 8th bright fringe. Minus minimum will be when the denominator is maximum. Denominator maximum means sin omega t maximum, right? So maximum is 1. So I can say 8 lambda d by 0.8 plus 0.04. Okay, this is the value you have to calculate. Lambda value is given, capital D is given to you. Get the answer. And okay, one more mistake. This I didn't put this value, so I don't have to take care. Here this is given in mm, so 10 is to the power -3. Okay, so it will go in numerator 10 is to the power 3, 10 is to the power 3. I have made a mistake here, so now it is correct. Okay, so you take this common, 1 by 0.76 and 1 by 0.84. Okay, this if you solve, I think it will come 601.5. Okay, 601.5. But actually in JEE Advanced, if you check the answer key, okay, they gave a range. Okay, I think 6.02 till they gave. Okay, and from the 198 or 199 something they gave. Okay, so generally in this kind of questions, if there is a calculation, very hard calculation, they give a range. Okay, but you should not be dependent upon the range, you should get the correct answer. Okay, so that's what here you can get the answer. Okay, now second thing he said, one more question in the same paragraph, the maximum speed in micrometer, okay, at which 8 bright fringe will move is, okay, maximum speed you have to calculate. Fine, hold on here. Maximum speed, see, y function came, so this is the way it is moving. Okay, how we, what is that, y is equals to how it is moving, 8 lambda d by small d, that is 0.8 plus 0.04 sine omega t. He is asking maximum value of velocity. This is the position. So velocity, what will be the velocity? dy by dt, right? So differentiate it. Okay, if I differentiate 8 lambda d by d is constant, right? Then first 1 by x differentiation, that will be minus. So negative sign is just for the direction, right? So I can say 0.8 plus 0.04 sine omega t whole square. Okay, and then this function differentiation, that will be how much? 0.04, and sine differentiation cos omega t, and then omega t, omega differentiation. So omega will come outside, cos of omega t. Okay, omega value is given to you, right? So this will be the answer coming to you. Okay, now he is asking the maximum value. This square is outside, this is function like this. Okay, understood? So he is asking the maximum value. Understood? So maximum value, how we will calculate? I think maximum only is asking. Maximum is speed. So maximum is speed when the numerator will be the maximum and the denominator will be the minimum, right? Okay, so magnitude only is asking. So magnitude I can say at t equal to 0, dy by dt, the velocity will be maximum, right? Why? Because this will be the this will be maximum, and this will hit the 1, and this will hit the minimum 0, right? So that way this function will, overall function will be the maximum. Okay, now one problem here is how you said that when this will hit the maximum, this will go 1, this will only the minimum 0, because it can go below that also, right? Negative also it can go, right? So that also possibility, by that you get a different answer. Okay, so that was one more, I think there should be a correction, but it was not correction. Okay, answer key already came, obviously. So this was here 1 only consider, and this is 0. Okay, at t equal to 0 if you do, then you get the V maximum. I think this comes 24 micrometer per second. Okay, this was the speed. Okay, so here 1, this is 0. So at that point of time we will be maximum at t equal to 0. Okay, so this condition satisfied. Okay, now see the next question, last paragraph, and 2 questions are left. Okay, now this paragraph is saying that, so 2 masses are there, 1 and 2. Okay, these are oscillating with the positions. You can read the question. Okay, so these kind of questions of first, this velocity of center of mass, this we have already done in the notes. Okay, basic question, velocity of center of mass, but this one more thing is introduced in the question. Okay, that's why it is looking little bit difficult. Okay, mass m moves towards the system with speed u0 a omega by 2. Okay, values are given to you, and then VCM is defined. How? See, velocity of center of mass is defined as particle 1 and 2 only. 3 is not including in the calculation of VCM. Okay, and oscillating with omega frequency. Okay, now see, here first thing we will do is velocity you calculate, particle 1 and 2. Okay, so particle 1 and 2, if I see particle 1, I can say that side particle, that will be a omega. So if I differentiate this, what I will get? A omega cos omega t, right? A omega cos omega t. Okay, and particle 2, what I will get? Minus a omega cos omega t. Okay, now he is saying in the question number 16, read the question number 16, at t equal to 0, what is the value of VCM by a omega? Fine. See, so at t equal to 0, see, understand what is happening here. If you calculate velocity of center of mass is at any time t, 0, right? Okay, means particles are, as keeping the center of mass here, they are oscillating like this. Okay, And at certain t equal to 0, what happened? This third particle came here, this side, and it hit it. Okay, so velocity, this velocity will change, right? This velocity obviously will not change. Why? Because spring is non-impulsive, right? That's why. So what is happening? See, understand here, at t equal to 0, what is the condition? Particle 1 and 2, right? So I can say particle 2 is here, spring, and then particle 1. Okay, so particle 1 is going with at t equal to 0, a omega, right? So a omega means this side a omega. Okay, and particle 2 is going this side with a omega at t equal to 0. Okay, and particle 3 is coming with a omega by 2, and they hit. Masses are equal given in the question. This collision is elastic. This is 1, this is 2, this is 3. Obviously you know. Masses are equal, collision is elastic. So nothing will be transferred to this velocity. Why? Because this spring is non-impulsive, right? So here the collision will happen. After collision, what will happen? After collision, if I see, then what will happen? 2 will have a velocity a omega by 2. And 1 will be same a omega only. And 3 will get the velocity of a omega. Why? Masses are equal, so elastic collision velocity will get interchange. So I interchange the velocity. Okay. Now he is saying find out the velocity of center of mass for this system. This is the 16th question. So VCM is what? M1 V1 plus M2 V2 by M1 plus M2. So masses are equal. So I can say M into a omega by 2 plus M into a omega divided by 2m. So from here, if I get what I will get, VCM is equals to 3 by 4 into a omega. So he's asking what? VCM by a omega. Okay. So a omega you take this side. So VCM by a omega, that is equals to 3 by 4 means 0.75. Okay. So that's my answer. Okay. So this is how 16th question is done. What I did here, just elastic collision. Okay. And then calculation. Understood? Now come to 17th question. Okay, if the collision occurs at t naught equals to pi by 2 omega, then the value of 4b square by a square. What is b? B he defined as amplitude, a new amplitude after collision. Okay, so that what is that value? You have to answer in if the collision happens at t naught equals to pi by 2 omega. Okay, fine. So first get the velocities at what he said at t 17th question. At t naught equals to pi by 2 omega. Pi by 2 omega. Okay. So if I get that pi by 2 omega, if you put here, what you will get? So here pi by 2, here pi by 2, right? So this will get 0, 0. Okay. So V1 and V2 are 0. V1, V2 are 0. And then this hit. Then the particle 3 will hit at this point of time. So before collision, this is the condition. Okay, V equals to 0, V equals to 0. V equals to 0 means what? V equals to 0 means these are at extreme position. Okay, these are at extreme position. So A is given to you. A was the amplitude here, right? So initial amplitude is A. Okay, see here, let me come. Okay, here, so before collision, this is coming with a omega by 2, right? This is coming with a omega by 2. Yeah. Okay, a omega by 2. Now what happened? Collision happened. Okay, so after collision, do the collision. After collision, I can say this in velocity interchange here also. So this is a omega by 2, and then V equals to 0. This is okay. This is just after collision. Okay. Now he is asking the amplitude, the new ratio. This is 4b square by a square. Okay, so how to get this answer, that you have to see. Okay, now two methods are there. One method is you go by the SHM or you go by the work energy theorem. Okay, in the frame of center of mass, both things will be in the center of mass frame. I will go with the SHM part. Okay, because that one will be the very fast and easy only. Okay, so first you calculate the velocity of center of mass in this case. So what is the velocity of center of mass first of all? Okay, what is that? I can say m1 v1 plus m2 v2 divided by m1 plus m2, right? So that is 2m. Okay, so this will come a omega by 4. Okay, so now draw this diagram with respect to center of mass. So what will come? This is here, center of mass in between, center of mass. So in frame frame of COM, I can say this will go with here, this side A omega by 2, right? So this is A omega by 2, center of mass going this side, so it will come A omega 4 this side, so this will go with this side A omega by 4, okay? And this is coming this side with A omega by 4. A omega by 4, okay? This is the condition, okay? So finally this is the condition, okay? I can say for this one particle only you write down, okay? I can say velocity is how much? A omega by 4 is equals to what? In condition of SHM, omega under root of B square amplitude square minus initial extension square. That is how much here it is. Here it was at maximum extension at that point of time. What was that? A. B square minus A square. Okay, that's how. Now if you solve from here, you will get the A and B ratio. Okay, understood? So how I did it? See. With respect to ground frame, this is the condition at initial, okay? Here what is the condition? Here the extension is A, okay? But now, this is the extension A, not the from the distance from center of mass. This is the extension A, okay? That is the amplitude, okay? Because both are oscillating. What is happening here? Initially, both are at maximum extension, okay? And these are oscillating like this, okay? Now you hit the particle. Center of mass started moving. Like this, they are oscillating continuously going ahead, okay? Because center of mass is moving with constant velocity. What I am saying is initial extension A, okay? Final amplitude became B, right? So what we write down in SHM, what we write down? Velocity is equals to omega under root amplitude square minus extension square at that point of time. So at this point of time, extension is A, okay? And amplitude of this new SHM became B, that he defined, okay? So this is the relation. Now if you cancel out, this came A square by 16 is equals to B square minus A square, okay? Take it this side, you will have 17 A square by B square, 16 B square is equals to, 17 by 16 A square equals to B square. What value is asking? Is asking 4b square by a square, okay? 4b square, so 4 you take this side, so you will have 4b square by a square is equals to 17 by 4, okay? So 16 by 4 plus 1 by 4, okay? That will be 4.25, okay? That's how I got the answer. This is one thing here you have to understand is this thing, okay? This part. When velocity changed, at that point of time, extension was A, okay? So A initial was amplitude, right? Here it was at the maximum extension, so means at A, right? But now when it got hit, okay? It got hit here, okay? After getting hit, amplitude became B. Now amplitude is something else. This is the extension only, right? So in center of mass of frame, I am writing this SHM, because in center of mass frame, this particle is performing SHM like this, right? So initially center of mass frame, he was performing SHM with A, right? A amplitude. Now he is performing with B. But at the time of A, when he was at the maximum extension A, that point of time you hit it, okay? These kind of questions are done in the SHM, basic questions, okay? At the time of maximum extension, if you hit, then what is the new amplitude, okay? That he gave B. So at X, A became X, okay? So this is the new condition here. Understood? So by that you got the answer, okay? I hope you understood. Paper 2 was not that much hard, but it was like logical and some questions are lengthy, okay? But overall 2024 physics was very scoring, okay? And obviously you have to focus on all the chapters, all the concepts, then only you are able to understand. Because here, see, if here only you see, then he mixed the center of mass and SHM, right? Collision also, everything is there, right? So I hope this is clear, okay? And you have enjoyed the lecture. Thank you.